Today we are going to be speaking more about volumes of revolution, but we are going to be focusing on revolving around other lines, other than the X or the Y axis. Monday we talked specifically about how to revolve something around the X axis and around the Y axis. Today we're revolving around other horizontal and vertical lines. We never revolve around diagonal lines in this class, that's it. Just horizontal or vertical. The process is exactly the same as before. The one difference is calculating what R is a little bit trickier. And that's what we're going to focus on today, is how to find the correct R value, which is just regular R if it's disk and big R and little r if it's a washer. Okay, before we get started on some sample problems, I want to list for you guys some key things that you need to remember as you do any kind of volume problem at all. So these are the keys to doing volume problems correctly. Key number one, and I've mentioned all of these before, but now we're just going to write them all down so that you have something to look at. Key number one says always slice through the axis of revolution. Always slice through the axis of revolution. Whatever line you're revolving around, you slice through that line. So after you draw your picture, you're like, wait a minute, well, which way do I cut it? You always cut it through the line you revolved it around, okay? Now, there were some keys from that line to know whether it was a dx or a dy problem, and I want to write that down next. If you are revolving perpendicular to the x-axis, if you are slicing perpendicular to the x-axis, it is one way, and if you're slicing perpendicular to the y-axis, it is another thing. One is dx and one is dy. This is the way you slice, not the way you revolve, but the way you slice. This is the same as it is for cross sections. If you slice perpendicular to the x-axis, which one is it, dx or dy? Dx. And if you slice perpendicular to the y-axis, it is dy. Okay. Now, the thing is, though, when you slice through that axis, it's pretty obvious that you're perpendicular to the x and perpendicular to the y. But what if it's not? Let's say that my hand is quadrant 1, okay? Y-axis, x-axis. If the line that I'm revolving around is over here, and I'm slicing through it with my finger, slice it through, and I kept going, which axis would I eventually hit? I would hit the y. That means it's a dy problem because it's perpendicular to the y. Slicing perpendicular to the y. If my line is this way, and I'm slicing through the axis of revolution, I'm eventually going to hit the x-axis. So that's considered perpendicular to the x, thus it's a dx. Okay? When we do sample problems, that'll make a little bit more sense, but I wanted to kind of give you an intro to that, as to how that works. Okay? Key number 2, all revolution problems Now, what do I mean by revolution problem? If a problem says revolve, or if a problem says around this line or that line or the other line, that's considered a revolution problem, are either discs or washers. Those are your only two choices for area. It's either discs or washers. Never squares, never triangles, never rectangles. It's always discs and washers. So you only have two to choose from when you're trying to decide what area formula to use. Okay? Rule number 3. This is big. Remember, quote, top minus bottom. Close your quotes. Or, quote, right minus left. For all values of capital R and little r. What I said about today compared to last time is the fact that the r's are more complicated. Top minus bottom and right minus left are what's going to make or break whether or not you write your R's correctly. And if you don't write your R's correctly, you will get the wrong answer. Guaranteed. Okay? That is a big one. Number 4 is also a big one. Big R and little r must, and I'm going to underline must because it's so important, go into the original piece. And as we do samples, I'll show you what I mean. When you draw a picture with a radius, you tend to want to draw the radius to the right, but drawing it to the right will give you the wrong answer in some cases. You have to draw it into the original piece. Okay? So those are the 4 keys to understanding and correctly setting up these volume problems. If you do these things, then you will get the right answer. All right? So let's go ahead and try in a sample problem. We're going to take the line y equals 3x. Let's scoot this up. Y equals 0 and x equals 2. Those are my boundary lines. Y equals 3x, y equals 0, and x equals 2. And we're going to revolve around x equals 2. Not an axis. We're revolving around something totally different. Okay? All right, step 1, let's draw this thing. Now, because I know what it's going to look like, I'm drawing a little bit skewed to the first and fourth quadrants. You may have to put it in the calculator to see exactly how to draw your axes before you get started. I'm going to do this one by hand, however, because this is a line. First of all, if you look at the second equation, y equals 0, that is the x-axis, which means it's not going to go below the x-axis. So I'm only really drawing in quadrant 1. So this line right here, what is its y-intercept? What's the y-intercept of this line? 0. And its slope is positive 3, which means it's going to go this way or this way? To the right, up and to the right. So I'm just going to draw a diagonal line like so. Good enough. I also know that y equals 0 is a boundary, which is the x-axis. Now this third line, x equals 2, this will make or break you getting this right, drawing this in the right place. Is this a horizontal line or a vertical line? It is vertical. So at x equals 2, I'm going to say is right there. I'm going to draw a vertical line. There's 2. And there's my shape. It is a triangle. Very light shading, so I can draw my slice. I am going around the line x equals 2, which is this right here. I like to draw in my axis of revolution with a squiggly line. That way you know where it is. So that is the line that you are going to mirror image your shape over. So this way, it'll go like so. What 3D object are we talking about here? It is a cone. It is a cone. Okay, once you've got your object in mind and what kind of shape it is, the next thing you have to do is draw a slice. Which direction should I draw my slice? Horizontal or vertical? Horizontal, because I have to go through the axis of revolution. Rule number 1, you must always slice through the axis of revolution. So that means I have to go horizontally. Otherwise, I will not go through that red line right there. So I'm going to draw the slice this way. And I draw the back side dotted because you can't see it. Okay. Does that look like it's going to be discs or washers? It looks like discs because the whole original piece here is touching the other side. Now, I'm going to take a different color just so you can see better to draw my radius. You're going to want to draw to the right. Do not draw the radius to the right. Rule number 4 says the radius must go into the original piece. So it's from the axis of revolution that way. It has to go that way. If it doesn't, you will get the wrong answer. Okay? So I'm going to write down, I know the slice is going to be a disc. I know the area of a disk is pi r squared. Here's where it gets a little interesting. Every year I teach this. This is the one thing that holds students back from being successful, is trying to understand what R is. And I think I've finally come up with a way to explain it that it will make the most sense. So what I told you on rule number 3 was when you're looking for R, you need to remember either top minus bottom or right minus left. Which one do you think applies to this radius? Right minus left, because of the direction that it's going. Okay? Now, where does the radius fall on the right-hand side? I'll give you a big hint. It's right there. It's at 2. So the right value is 2. Now, is the equation of that line x equals 2 or y equals 2? What's the equation of that line? X equals 2. So I'm looking at x values. Okay? So the right equation is 2 minus the left equation. Now, the left equation is the diagonal line. You agree with me there? Okay? Now, is it the x coordinate of the line that tells me where I am, or the y coordinates? Now, this is where it gets a little tricky. Let's pretend that this point is the point 1, 3, which is a point on the graph, okay? How long is that segment right there? You can actually tell me numerically how long that segment is. Is it 2 minus 1, or is it 2 minus 3? It's definitely not 2 minus 3, because then I have a negative answer. Agreed? It's 2 minus 1 because the x coordinate tells me where I am horizontally. So it's 2 minus x for my radius. If I sliced lower, it would be 2 minus the x coordinate right there. If I sliced way up high, it'd be 2 minus the x coordinate right there. Now, if you're still a little bit confused about, wait a minute, how did you know it was x, Miss Bell? Here's another way to remember it, okay? Does this radius go in the x direction or the y direction? Which axis is horizontal? X. So the R value in your problem will be in x because it's a horizontal radius. If it's a vertical radius, it'll be a y. And if you look back at your homework that you did yesterday, every time the radius went up and down, it was a y. And every time the radius went sideways, it was an x. Okay? Same rule applies here. If it's a horizontal, it's going to have an x in it. If it's a vertical, it's going to have a y in it. Okay? That's a good way to keep it straight. But you've got to remember that it's right minus left. So let's go ahead and write that down. Right minus left. Okay? Now to find the volume. The volume is going to be the integral of the area equation, just like before. Pi times r, which is 2 minus x squared, d what? dy. Okay, why is it dy? Because if I take my chainsaw or whatever slicing instrument I'm going to use and I slice this piece out and I keep going past the cone, I'm eventually going to hit the what axis? The y-axis, so it's a dy. Okay? Go this way, I'm going to hit the y-axis. If I go this way, I'm going to hit the axis. So this is a dy. Okay? This for reasons. Number one, it tells you what letters have to be in here. And number two, it tells you what to look at on your picture for your limits of integration. If this is a y, I need the y values for the original piece. What's the lowest the original piece goes? 0. Now, that's the highest it goes. That's the highest my cone goes. What's the coordinates right there? 2, 6. Do you all agree with that? So is the limits of integration 0 to 2 or 0 to 6? 0 to 6. Very good. All right. That was kind of intense. Is this ready to go in the calculator? Nope. I need to change my x to a y. So where is the relationship between x's and y's? It is right here. So I'm going to, for emphasis, what does x equal? 1/3 y, or you can just write it as y divided by 3. You should divide both sides by 3, right? So when I go to write the volume again, I'm going to pull the pi out, 0 to 6, 2 minus y over 3 squared dy. Calculator, here it is. So let's do our pi. Actually, I'm going to leave the pi out for a minute. I'm going to show you why. I'm going to do my math 9, 0 to 6, parentheses, 2 minus alpha y over 3, close the parentheses, squared over dy. You can type in x's if you want to. I just decided to type in y's. And when you push enter, you get the number 8. So, is 8 the final answer? No, it's 8 pi. Sometimes, especially when you're doing multiple choice, you need to look at your answer choices before you throw things like this in the calculator. If the answer choices say 4 pi, 8 pi, 2 pi, don't put the pi in the calculator, because otherwise you're not going to match any of them. Leave the pi out and then do the math and then tack your pi in the answer. Questions? All right, we're going to do one more problem. Hopefully I have enough room. I kind of was very generous with my paper here. So we're going to squeeze the equations in here. Y equals x squared, and we're going to go around y equals -1. Y equals x squared around y equals -1. This drawing is rather tricky. I'm telling you right now. You actually found the area of this piece on the area worksheet. So what I want you to do is go to the calculator, type those two equations into y equals, like this, just y equals x squared, and then I want you to push zoom 4. Because I have a curve involved, that now I'm pulling out the calculator. Okay. Do you remember graphing this on the area worksheet and looking for that teeny tiny little sliver in quadrant 1? Do you see it? Where do those two pieces cross? Do you know? Can you tell by looking? It looks like it's 0 and 1. It does. So what I'm going to do is I'm going to zoom in some by setting my window from 0 to 2 in both the x and y directions. So 0 to 2. Whoops, and 0 to 2. This way you'll get a really nice picture of what's going on. So push graph. There you go. So the top is straight, the bottom is curved. And that's what you need to draw, is just up to there. Just that up to there. Okay? So I'm going to pull this aside, straight out of here, curved out of there. Now, because I didn't draw my axis on a line, it's going to kind of make things a little bit interesting. Now, my axis of revolution, is it horizontal or vertical? It is horizontal. It's going to go this way. The thing is, though, this line does not even touch this piece, and that's okay. So what I'm going to do is I'm going to shade this in, because I'm going to have so much on here, it's going to kind of be confusing in a minute. And I'm going to squiggle in my axis of revolution right here, and I'm going to write the number -1 out to the side, because that's where it is. Now be very careful when you draw your mirror image. You're going to want to start it right on the line, but realize that this doesn't even touch the line, so I've got to go that far away on the other side to draw the mirror image. So this one's going to start right there. Do you see what I'm doing? This is like the width of a line away, so this one's going to be a width of the line the other direction. Straight on the bottom this time and curved on the top. Does that even look like a 3D object? Does it look like a whole object? Not really. Okay. So what I'm going to do is add in a few more pieces, and then I think you're going to see this is a lot of real world objects. We came up with about 10 of them last period of what this really is. Take these 2 points on the left and connect them with an oval, like so. Connect them with an oval. That's the top view. That is the top of it, basically, because it's on its side. Then take the two pieces on the far right, those two, connect them with a curve outwards, and then a dotted line curve inwards. What do you see on its side? Yes. Does it look like a Christmas tree stand on its side? Your little tree goes like this. A lampshade is the one that I saw first. Okay. A volcano, I can see that too. A speaker. Yeah, that's a great one. A speaker. And actually, that's the direction a speaker would go. A megaphone. Do you see a megaphone there? Okay. A lot of different things that this could be. So, we've got to hurry up and finish this. Is it going to be discs or washers? Definitely washers. It's got a huge hole in the center. So I'm going to draw two slices. I'm going to draw an outer radius slice that goes all the way from the top to the bottom. And then I'm going to draw its radius in. Remember, the radius has to go to the original piece. There's the big R. And then I'm going to come over here and draw a inner circle away from that one so that I can draw and label little r and you can see it. That's what makes this kind of challenging. I'm not putting the little radius inside the big radius because it's just too hard to see. It's even hard to see now. Okay. The slice is a washer. The area formula, and you have got to memorize this formula. Pi parentheses big R squared minus little r squared. And then we've got to find out what big R and little r are. R. Okay. I'm going to use my two pens to point. Okay. Here is big R. Do you see the top and bottom dot? Do you see that it is top minus bottom? Okay. Which direction is it going in, X or Y? It's going up and down, so it's going in the Y direction. So any variable I put in R is going to be a Y. Okay. Now here's the question. I have two Y's over here. I better distinguish which is which. This is Y1, this is Y2. Okay. Which one is the line, Y1 or Y2? This is Y1. Let me point back again to where I was pointing. So what is the top of the big radius, the top of the blue line? Y1 or Y2? Y1. So let me get another color here. 1 minus, what's the bottom of the blue line? Where's it at? It's on -1. So it's Y1 minus -1. Parentheses top minus bottom. Do you see that? Top is Y1, bottom is -1. Okay, for 30 seconds, talk to your table. What do you think little r is going to be? Look at the red line right here, little r. What is little r going to be? Goes from here to here, here to here, here to here. Is it going to be Y also? Yes. They'll always be the same. Big R and little r. If you're using Y's, you're going to use Y's for both of them. Okay. What is top of little r? Y2. What is bottom of little r? -1. And it's top minus bottom again. Okay. So now I'm going to leave it like this because I know it makes plus a positive. I'll fix it in the integral. I want it to be this way to show that it's top minus bottom. Okay, so my volume is going to be the integral of pi. Now, my big R is two terms, so I've got to put a double parentheses here. So it's going to be Y1 plus 1 squared in the first parentheses minus little r, Y2 plus 1 squared, close it, close the whole thing, dx, because notice both the radiuses go through the x-axis, dx. And we talked about where these cross. They cross at 0 and they cross at 1. They're x-coordinates, 0 and 1. Now, because I'm using y1 and y2, and y1 and y2 are in the calculator, I could type that in just like that. Or you can change it to x's if that's more comfortable for you. So put the pi, 0 to 1, parentheses. Now, I don't need that outer parentheses anymore because the pi is outside. y1 is x plus 1 squared minus y2 is x squared plus 1 squared dx. There it is without the y1s and y2s. So if you type that in, and we're running short on time, so I'm just going to tell you what it is. It is going to be, without pi's, 1.466, and with pi's, it is 7 pi over 15. So either answer is correct, whether you put the pi in or not. Okay. Questions?